Solar system debris is a general term referring to all objects not considered a star, a planet, or a moon. They're all part of the junk of the solar system, the pieces parts, the things that we rarely ever know are there. So why are they important? What roles do they play in our solar system? In this video, we'll go over the properties of what makes solar system debris. And then we'll talk about them individually in the upcoming series of videos. Stay tuned. Why is debris an important part of the solar system? First and foremost, we don't need to go to them, they come to us, often catastrophically. But let's not get ahead of ourselves. Our solar system was thought to have formed from a solar nebula through the process of accretion. Tiny particles collided and stuck together through electromagnetic and gravitational forces. Over time, the particles grew in size. As they grew larger, gravity increased and the collisions became more frequent. Roughly speaking, the pieces over time grew to planet-sized and formed the solar system as it appears today. The existence of debris represent the pieces of the growth process that did not become part of a planet. The debris is vital to our understanding of the initial conditions of the solar nebula. These smaller pieces were not subject to the heat of compression or collision. This allows them to remain undifferentiated. Simply put, material likes to separate according to density. This is referred to as differentiation.
There are two different types of beads with different colors and different densities immersed in a fluid. We begin our demonstration by shaking up the bottle and completely intermixing the beads and fluid. Note that the two types of beads quickly separate, with the low-density white beads rising to the top of the fluid and the high-density blue beads settling to the bottom. However, as we continue to watch, note that the white beads start to settle and the blue beads start to rise. Note that this portion of the video has been sped up. This occurs because there are really four substances involved here: two types of beads, rubbing alcohol, and a saltwater solution. After shaking, the combined fluid mixture has a density in between the densities of the two beads. However, over time, the two fluids start to separate, and our final layering is entirely due to density. Alcohol with a density of about 0.8 grams per centimeter cubed on top, then white beads, blue beads, and finally a salt solution with a density of about 1.3 grams per centimeter cubed on the bottom.
High-density substances want to sink, whereas low-density substances want to float when mixed together. Planets in their early molten stages of growth separate such that the lighter elements float to the crust or surface, and the more dense elements float towards the core. That means that we cannot determine the chemical makeup of the initial material because we see only the lighter elements on the surface of differentiated bodies. Fortunately, debris is largely undifferentiated. Another important characteristic of debris is the presence of volatiles. Volatiles are molecules that turn to gas at low temperatures. They therefore are easily lost to space by small bodies. Water is a great example. Because these small bodies are not subjected to heat, they will likely retain volatiles in the same quantity as the solar nebula. If these small bodies impact a planetary body, like Earth, they bring these materials with them. We can also get the spectra of debris and see what elements they contain, all pointing back to the initial configuration of the solar nebula. We can also learn other details of the solar system evolution by properties of debris. The accretion model also predicts the presence of a frost line, a line defining the distance from the protosun, where conditions are too hot for gases and ices to condense. This is our dividing line between the terrestrial and Jovian planets. The frost line lies between the orbits of Mars and Jupiter. The presence of small icy bodies in the inner solar system would therefore not be a natural occurrence, since small icy bodies would not be expected to form inside the frost line. And finally, our debris will include the following bodies and their distinctions. Comets, a small chunk of ice originating from the outer solar system, often accompanied by a coma and tail. Asteroids, a rock in orbit generally between Mars and Jupiter. Sometimes asteroids get bounced towards the Earth. Meteoroids, a space rock that's bigger than a dust grain but smaller than an asteroid. If it strikes the Earth, then it becomes a meteorite. Meteor, the streak of light seen when a space rock enters the atmosphere and starts burning up. We usually refer to this as a falling star. And finally, meteorite. If a meteor doesn't entirely burn up, a piece of space rock that lands on Earth is called a meteorite. We will discuss each of these in separate sections as a part of this series.